Okay, real quick. Here is our original pre-image, okay, the original polygon. Here is our translation vector. Notice what it's telling you to do. It's telling you to take every x and y coordinate and change it to x minus 4, y plus 2. So in other words, take every x value and subtract 4 from it. Take every y value and add to it. Add 2 to it. Okay? What would that do to all of these coordinates if you were to subtract 4 from every x value and add 2 to every y value? What would that do to these coordinates? Move them left 4 and up 2. If you think about this, if you subtract 4 from the x values are going to get smaller, right? And when x values get smaller, which way does that move things?
Negative.
Towards the negative, right? Or towards 0 or into the negative, whatever it might be. If you add 2 to y values, so like if you add 2 to that 3, it becomes a 5, right? Won't that be further up on the graph? By 2? So really what this is saying is take every coordinate and move it to the left 4 and then move it up 2 units to get your new coordinates. Alright? I'll do that in red here. Okay? So I'm going to take this k value, 0, negative 2. I'm going to subtract 4 from it. So that'd be negative 4, right? And I'm going to add 2 to it. That'd be 0. So negative 4, comma 0. So it would be right here. Now you could do the math, or you could have just, from right here, you could have said, okay, I got to go left 4, 1, 2, 3, 4, and then up 2.
That's
Okay?
what I would have done.
So however you want to do it. And this new point is called k prime. Okay, it almost looks like k with a little 1 there or an apostrophe right there. It's called k prime. We're going to do that for all of the coordinates. Alright? We're going to take L and move it left 4 and up 2. So then L prime would be located at 4 minus 4 is 0, 3 plus 2 is 5. Okay, so there's L prime right here. M prime, 1, 2, 3, 4 left and 2 up. It would be located at 1, comma 4. That would be M prime. And then N would be moved 1, 2, 3, 4 over and 2 up. This would be N prime
2,
1. Right? And then here is your new image.
So when we do this on test, do you want us to write out the new coordinates?
I'll ask specifically for you either to write out the new coordinates or to graph the new coordinates. Or both, potentially. But be able to do both in a sense. Okay? The red one is called the image.
So silly.
The blue one is called the pre-image.
So the blue one.
The red one is called the image, the blue one is called the pre-image. How do you know which one is which? Look for those little prime notations. Okay, when you see these problems in the book. As soon as you see those little prime notations, you know that is the new image. That is the image after the translation vector has been applied.
So can some of the pre-image have like the primes or no?
The pre-image will not have the primes on it. That's like your starting shape, your starting polygon. Okay? It's our beginning point. So we have this shape, and then we got this vector, this force acting on this shape. This particular vector right here took that shape, moved it left 4 and up 2, and then here's where we're at now. Okay? This is an example. I'll come back to the slide, but for the speed of the video, this is an example of an isometry, or isometry, however you want to say it.
Write this down.
I would know this vocabulary word, yeah. Basically all this is a congruent transformation. That basically means all it did was move it. Didn't change it, didn't stretch it, shrink it, didn't do anything like that. It just took it and moved it. Okay? It's like you dragging an image on a document. Oh, I don't like it in the top right corner. I'm going to move it to the middle. and you just drag it to the middle. You're not dragging on the corners or the ends of it that stretches it or shrinks it or makes it bigger, okay? It's a congruent transformation. So it doesn't change its size or shape or angles or anything else, okay? This says no change in size or angles, if you want to write that down. But basically it just keeps its same shape. Okay? Alright, any other questions that you guys see on this? Still going. Good. One last thing then. What if you don't need to draw this?
No, you silly.
What if I gave you the pre-image and the image and told you to write the translation vector?
Just go from one spot.
Just kind of do the opposite. So you try to figure out how far it was moved left or right, and then how far it was moved
Up and down.
up and down. So just pick a coordinate. Doesn't matter which one you pick. Let's take A. It got moved 1, 2, 3 to the right, and 1, 2, 3, 4, 5 down.
So plus 3.
X plus 3 because it got moved 3 to the right.
Minus 5.
Y minus 5
Going down.
because it got moved 5 down. That would be the translation vector to represent that translation.
Or we just find the points and add 4 and then subtract 2.
We don't need to know the points though.
Say that again.
Then we just find the points and like add 4 and then do the opposite, like always subtracted 4.
Oh yeah, yeah. If you knew the coordinates and that sort of thing. I didn't put a axes on here, so yeah. Okay. All right. Okay on this.